What controls temperature? And there's several factors that control temperature. And these factors cause temperatures to vary from place to place and also from time to time. So keep that in mind. The first one, and one of the main ones, is latitude. Where you're located in respect to the sun's direct rays makes obviously a huge difference to what your temperatures are going to be like. You live near the equator versus living near the poles. Big difference because you are in one area, the equator, much closer to the direct rays of the sun than you are if you are up in the polar regions. You're going to get that increased solar angle, and it's going to make it, you don't get as much intense solar radiation, therefore the temperatures are a lot lower. So most places, the main reason why the temperature is the way it is, meaning it's the way it is during the summer versus, the way it is during the winter, cold winter, warm summer, whichever the case may be. Now, Kansas City, their number one reason why the temperatures are the way they are, where we have hot summers and cold winters, but not like Arctic cold, is our latitude. We're about 39 degrees north in latitude, and that's just about in the right location where you'll get these seasonal changes. You'll get a warmer summer, and you'll get a colder winter. Another one is the distribution of land and sea. Now, something you need to remember that will come up many times is that land heats up more rapidly and to a higher temperature than water does. So land heats up faster and it goes to a higher temperature. And that means it also cools down faster and can go to a lower temperature than water. Makes a big difference. Now look at the distribution of land versus sea for the globe. You got the northern hemisphere on the left, and you got the southern hemisphere on the right. I'm just looking at them from top view down. What do you see? Obviously, there's differences in how much land versus how much water is distributed at the North Pole versus the South Pole. Makes a huge difference on what your temperatures are like in the northern hemisphere versus the southern hemisphere. So, looking at it and thinking of it that way, so why is it a big deal? Why does land heat up faster and to a higher temperature than water does? Well, look at it this way. Water is more mobile, so it moves around quite a bit. It has what they call convection currents, and it can redistribute the heat. The top of the layer warms up, then that can be replaced below by the colder water. So you get this convection current setting up. Land is not mobile. It's opaque. It's a hard surface, and it absorbs in a really shallow layer. Hence, it can heat up faster and to a higher temperature, or the colder faster and to a lower temperature. Water is transparent, so that means heat can pass through it, whereas land isn't that case. And for water, too, evaporation is a cooling process, which is something we'll look at when we start to do clouds, and that can help slow the process of heating down. Another way to look at it, so you've got your land. It doesn't penetrate through. It's right, everything's absorbed in that shallow layer, so it's going to heat up a lot faster versus the water where it comes down and it's got a lot more depth it can go through. So you have to heat all of this to get it up to the same temperature as you would just this one thin layer of the land. So obviously land can heat up a lot faster in that case. And you can look at it based off of temperatures for two locations. You got Vancouver and Winnipeg, both in Canada, both roughly at the same latitude. You can see where they're located, Vancouver versus Winnipeg. Winnipeg is what we'd consider a continental location because it's not around any close, larger bodies of water, whereas Vancouver is what they consider a marine climate because it sits right here in the English Bay, which is part of the Salish Sea. So you can see the difference between the two climates. Vancouver, just on the bottom, January through December. And this is temperature in Celsius, which if you don't know how that relates to what you're used to, it's not a big deal. But you can see that overall, Vancouver has a very mild change throughout the entire year. So going from winter to summer isn't a huge change. Winnipeg, being the continental location where land will heat up and cool down faster, whereas Vancouver, with it's next to the large body of water, it doesn't heat up and cool down as fast because it's water. It takes a long time for it to happen because it's mobile, and it will allow the sunlight to penetrate in further, so it takes a little bit longer time for the water to heat up. But the Winnipeg one does. So you have a distinct winter versus a distinct summer. So huge changes from one to the other, whereas you see the one here for Vancouver, it's a slight curve, and there's obviously changes from summer to winter, but it's not dramatic like it is in Winnipeg. So that shows how water doesn't heat up as fast as the land does. So if you live near a coastal climate, your temperatures year-round are a lot more steady than if you lived a lot further inland. Oceanic circulation is another one. This is a big one. You have to have this. This is extremely important for the oceanic circulation. It drives the weather conditions across the world. Hurricanes are the most efficient way to transfer energy from one location to the next. Basically, they form down in the tropics where it's a lot hotter, and it can distribute that heat on up into some of the upper parts of the latitude. So it distributes a lot of heat energy around. They're actually really important to have hurricanes. It sucks if it comes in your location because they can do some damage, but it's a very important process for weather. And the oceanic circulation redistributes about 35 to 40% of all the heat energy that's in the earth. So it does a really, really good job. And when you look at it, I mean, look at these. The red is all the warm currents, all the blue is all the cold currents. And kind of notice a couple things. You have the cold current along the California shoreline. So if you've ever went out to California and took a dip in the Pacific Ocean, very chilly waters because it has that cold current where it's bringing the colder waters from further up north on down, versus if you're on the Atlantic side, if you ever visited along the Jersey shores, Georgia, Florida, it's a much warmer water because you've got this what they call the Gulf Stream. All the warmer waters from the equator are moving up along the coastline. And basically all this is doing is redistributing energy. You've got colder waters at the pole, you've got warmer waters at the equator. The Earth cannot stand to be out of balance, so it tries to fix that by moving stuff around. That's how the atmosphere works. You can't have one area being really, really cold and one area being really, really hot. You have to mix that. The Earth would like to be uniform across the globe on everything. It obviously is never going to get to that point, but it always strives to hit that. So the oceans are no different. You get warmer waters in the equator, colder waters towards the poles, and it's going to try to mix all that stuff together in order to redistribute all the energy. Notice a couple things of these currents in the northern hemisphere versus in the southern. They go clockwise in the northern and counterclockwise in the southern. And the only reason why they have that clockwise or counterclockwise motion is because there's land that's in the way. You look at this west wind drift, there's a big chunk of the water where there's nothing blocking it. And so there's no turning motion to it because it's just moving across the entire globe. So again, oceanic circulation. And this would affect a lot of all the locations that are along the coastlines. Another thing that it does is if you're on a cold current side, it tends to stabilize the atmosphere and you'll have drier conditions. Again, that doesn't mean you can't get a storm system in and get rain and that kind of thing, but typically if you're on a cold current side, there's one along South America, the California coast, your atmosphere is a lot more stable most of the time, and it tends to keep you a lot drier. If you were on a warmer side, then your weather is more on the unstable side, so you can get a lot more precipitation on those sides versus on the colder side. So colder air will tend to stabilize. Even if you get colder water, it'll help stabilize the atmosphere, versus the warmer water will unstabilize the atmosphere. So that's your oceanic circulations. Cold currents, more stable atmosphere; warm currents are the unstable. Another one is atmospheric circulation. And this is an overall flow pattern. And again, we'll check out this when we do planetary circulation. But it's the same premise of you've got warmer temperatures at the equator and colder temperatures at the pole. Warmer air tends to rise, so if you have rising air motions at the equator, eventually they'll have to sink back down, and that happens at 30 degrees north or south in latitude. And what it ends up doing is it creates this band of high pressure at 30 degrees, and you will find almost all of your world deserts at 30 degrees north or 30 degrees south because of this pattern. And again, you'll have the air sinking here. Everything has to move. It's like not going to rise up and then just go on forever. It obviously hits the top of the troposphere and then it redistributes. When it's coming down towards the ground, it doesn't go through the ground. It's going to hit the ground and spread out. And so your motions are constantly moving about. And so we'll look at atmospheric circulation. That's more like for everybody has the same. This all controls temperatures for everybody. One that's a little more specific would be temperature controlled by altitude. So you know if you go up in a mountain, then the temperature generally drops. So as you go up in the atmosphere, temperature lowers. So cooler temperatures at higher elevations. So that's what number 5 is. That's one that everybody should know. Another one is what we call geographic positions. And that would be stuff like being on one side of the mountain versus another side. If you're on what's called the windward side of a mountain, you get cooler summers and winters are a little more mild. Leeward sides tend to have a lot more drier conditions than the windward side. And again, this is stuff we'll look at in the upcoming weeks too. That can make a big difference. If you live in downtown Kansas City versus one of the outlying areas where you don't have as much buildings and asphalt and that kind of thing, that urban heat island will make a big difference in your temperatures, which is why the official thermometer of Kansas City is at KCI and not at downtown, because downtown's temperatures are a little bit more skewed because of that urban heat island effect. Cloud cover. Cloud cover is another one. Cloud cover is a big deal. If you have a lot of clouds during the daytime, your temperatures are lower than what they would have been. If you have clouds sticking around at night, your temperature will stay warmer than it would have if there were no clouds. So clouds can act like a blanket. They can trap the heat in, or during the daytime they can keep the heat out from the sun.